will start with lesson 3. And lesson 3, what actually is focused on is finding the component of the vector. Okay, in order to find the component of a vector, what we will do is we will follow those 2 little steps. So we know now that we can represent a vector in northeast, southwest axis. And if we have a vector that looks, let's say, like this, with 120 meters at 30 degrees north of east, then we can create a right angle triangle that includes the given angle. So from the tip of the vector, we have 2 opportunities to go, in this case, to go north and to go east. However, the very first step is saying that create a right angle triangle that includes the given angle. If you go north, then it doesn't include the given angle. So what we do is we draw a perpendicular, creating a 90-degree angle with, in this case, with the east axis. On this way, what do we have? We are breaking this vector, let's say vector A, down into 2 components or 2 little parts. One that is going along the horizontal, and this is known as the horizontal component, and the other one that is going along the vertical. So it's a vector that goes like this. And this is known as the vertical component. Okay, now when we did the review of trigonometry, we dealt with a right angle triangle, and on this case we will be able to find what is the horizontal component and what is the vertical component of this vector using sine and cosine trig ratios. However, we have to keep in mind that sine is important. What do I mean by this? So in the attached northeast southwest axis, what we do is we kind of overlap in our mind x, y axis as we know in math. So whatever is into the horizontal right is considered to be positive, and whatever is vertical up is positive as well. But horizontal left is negative and going down is negative. So this is telling us that anything that is in the first quadrant, so when we have a north of east, both the horizontal and vertical are positive. Okay, and when we are in the second quadrant, in this quadrant here, then horizontal is a negative and a vertical is positive because it goes up. And when we have a vector that is between south and west, so we are on this quadrant here, then horizontal and vertical are both negative. And when we are on the fourth one, on this one here, the horizontal is positive and the vertical is negative. Now, very often in math, if it is positive, we do not state it because we assume that is positive. In the physics, we will state it because in physics, stating it as a positive or a negative tells whomever reads your paper that you are talking about a vector quantity, not a scalar quantity. So in math, when we say, let's say 75 when we say 75, we assume that is positive 75. However, in physics, if we say 75, then we are talking about a scalar quantity. In order to make the distinguish, to make it clear that we are talking about a vector quantity, we have to say positive 75. This positive sign here tells us that you are dealing with a vector quantity. Is this clear? On the theory, how to find the components and why stating the positive sign is important? So let's find now the horizontal and the vertical component of this F1 vector. So it's a force, F1 vector with magnitude of 20.0 newtons at 35 degrees north of west. So see now, it is important to know how to represent the vector in the north, east, southwest axis. This vector is between north and west. North and west. So we saw that it's starting from west. It's going at 35 degrees. So this vector, this angle here is 35 degrees. And it has a magnitude of 25. So this is vector F1 that is 25 newtons, and this angle here is 35 degrees. Okay, so now the little two steps that we do to find the component is from the tip of the vector, we create a right angle triangle that includes the given angle. So in which axis are we going to draw that? In north or in west axis? If you can answer me on the chat, that will good. So we'll draw it with the west axis. So this will be the right angle triangle that is formed now. And just for simplicity, so that you can see it better, what I will do is I will bring that triangle as a separate triangle here, as a normal right angle triangle that we have solved on the previous lesson. Not quite previous, but on the lesson 1. So we have a right angle triangle that looks like this. This angle is 35 degrees. And the length of the line segment of the hypotenuse is 25 newtons. So now, this being the horizontal component of this vector, so F1 horizontal, and this being the vertical component of this vector, so F1 vertical. Are we able to find the horizontal and the vertical component of this vector? Meaning, are we able to find the opposite and the adjacent of the 35-degree angle? Answer me, please. So now, if we are finding the vertical component, then you will use the opposite. So this is the opposite actually. So we will use sine. So we will write it like this. Sine 35 is equal to the opposite, which actually is the magnitude of the vertical component over the hypotenuse. And the hypotenuse is 25 because it represents the length of the line segment of the vector, magnitude of the vector. So this will be the vertical component of this vector over 25. Now, how can you solve for this? This is a simple math now. The vertical component of this vector will be 25 times sine 35 and using your calculator, making sure that the mode of your calculator is on degrees, you will find as 14 point, and the calculator is giving you like a long digital, a long, not digital, but a long decimal. I don't need all those. Very often I ask for 1 or 2 digits after the decimal point. And just for simplicity, we will say that is 2 digits after the decimal. So F1 vertical, or the vertical component of the vector F1 is, now the calculator is telling you 14, but is this positive or is it negative? On the chat, guys. It is positive because it is going north, yes. And in order to say that we are dealing with a vector, we have to state the positive sign, even though that, as I said, it is in math, we don't use it. It is omitted, is assumed. But in physics, since we are dealing with a vector quantity, in order to show that you are dealing with a vector quantity, you have to state the positive sign. And now let's figure out what is the vertical component, horizontal component, which is this one, this vector here. So in this triangle, the horizontal component is the adjacent. So we will use cosine. Cosine 35 degrees is equal to the horizontal component of vector 1 over 25. So from here, we can find that the horizontal component of this vector will be equals to 25 times cosine 35. And again, make sure that the mode of your calculator is correct. And this will be, now, since we are dealing with going west, will be negative, and it is negative 20.48 newtons. This example is asking again to find the horizontal and vertical component when we have a 32 newtons at 43 degrees west of north in this case. So I will draw the vector here. We are dealing with a vector that is between north and west. And now it is starting from north. It is going at 43 degrees. This is 43 degrees. And it has a magnitude of 32. F2 equals 32 newtons. Okay, so now let's follow the little 2 steps. From the tip of the vector, we will draw or create a right angle triangle that includes the given angle. That means that you will draw a triangle that is, or a line that is perpendicular to the north axis. Okay, so this is the right angle triangle here. Now, whatever is going along the vertical is the vertical component. So this will be the vertical component of this vector, F2V. Whatever is along the horizontal will be the horizontal component, F2 horizontal. Since we are here, what is the horizontal component, the sign of the horizontal component and the vertical component? Positive or negative? Good. So vertical component is positive because it's going north. horizontal component is negative because it's going west. Let's find now what is the horizontal component and the vertical component. So for the horizontal component, what the horizontal component is in the relation to 43 degrees is the opposite. So we will go sine 43 is equal to the horizontal component. You can say F2 horizontal, or you can just say horizontal, I don't mind, over 32. From here, we find that the horizontal component is equal to 32 newtons times sine 43 degrees. Again, make sure that you are dealing with the correct mode of your calculator. This is a common mistake. So F2 horizontal is negative in your calculator is 21.82 newtons. And then the vertical component is the adjacent, so will be cosine 43 is equal to F2 vertical over 32. From here we find that F2 vertical is equal to 32 times cosine 43 degrees. And again, make sure that you are dealing with the correct mode, and then you will find that F2V is positive, and we state it because we want to show that we are dealing with a vector quantity, 23.40 newtons. Do you have any question on this? Okay, let's move now to the next one. So we have a vector that is between east and the south. It is starting from east, moving at 30 degrees angle. This is 30, and with a magnitude of 27. So this is vector F3 with magnitude 27 newtons, and this angle is 30 degrees. Okay, let's find now the horizontal and vertical components. So create the right angle triangle with the given angle. Whatever is on the vertical will be the vertical component. So this is F3 vertical, and whatever is on the horizontal will be the horizontal component. F3 horizontal. Now, the horizontal component is the opposite of the 30 degrees. So sine 30 is equal to the horizontal component of the vector over 27. From here, F3 horizontal will be 27 times sine 30. So therefore, F3 horizontal is positive because it's going in the east direction, and it is, what is 27? It is 13.50 newtons. And for the vertical component, we will use cosine. If you use sine for the first, then it's cosine for the second. F3 vertical over 27 from here. F3 vertical will be 27 times cosine 30 is 23 point, no, here, F3 vertical will be negative 23.38 newtons. Does it make sense? Guys? Okay, let's move now to the next example. Super. It's between west and south. So west and south is something like this, starting from south, 40 degrees. So this is F4 as 18. And we have 40 degrees here. Create a right angle triangle that includes the given angle. So whatever is on the vertical will be the vertical component. This is F4 vertical, and whatever is on the horizontal will be the horizontal component. F4 horizontal. Now, the horizontal component is sine. It's not always sine. You have to look at the triangle and see what is it. Okay, so sine 40 is equal to the horizontal component over 18. From here, the horizontal component will be 18 times sine 40. So the horizontal component as a vector now will be whatever 18 times sine 40 is 11.57. But since it is going west is negative 11.57 newtons. And then the other one is cosine. So will be F4 vertical over 18. From here, F4 vertical will be 18 times cosine 40. So F4 vertical is negative because it is going south. So it will be negative 13.79 newtons. It's good to do the calculations while I'm working on those calculations as well, so that you can check for yourself. Because a common mistake that the students do is they forget to convert the mode of the calculator, and especially for the one that is they are taking math. Let's move now to the next example. So we have an F3 at 25 with a magnitude of 23 newtons and at 25 degrees north of east. So it is between north and east. And we are starting from east, going north at 25 degrees. So this is 25 degrees. And the magnitude of this vector, this is F5, is 23 newtons. So from the tip of the vector, we draw or create the right angle triangle that includes the given angle. So perpendicular will go here. Now, whatever is on the horizontal will be the horizontal component. So this will be F5 horizontal. And whatever is on the vertical will be the vertical component. So this is F5 vertical. Now, the vertical component is opposite of 25 degrees. So will be sine. So sine 25 is equal to the vertical component over 23. From here, we find that the vertical component will be 23 times sine 25. So 23 times sine 25 will be 9.72. It is positive, but since we are talking about a vector, we will state the sign as the positive sign. And then the horizontal component is the adjacent of 25 degrees. So cosine 25 is equal to F5 horizontal over 23 newtons. From here, F5 horizontal will be 23. If I'm asking you to show your work, this is what I want from you. F5 horizontal will be cosine 20.84 newtons. Since it is going in the east direction, is positive. So this will be the and we have to state the fact that it is positive. Clear? Find the horizontal component and the vertical component of vector F6 that has a magnitude of 20 and it is 30 degrees north of east. Again, between north and east. But now you are starting from north. You are going 30 degrees from north. So this is 30. And the magnitude of it is, this is vector F5. The magnitude of it is 20 newtons. Let's create the right angle triangle that includes the given angle. So it will be this one here. Whatever is on the horizontal will be the horizontal component. So this will be F5 horizontal, and whatever is on the vertical will be the vertical component. So this is F5 vertical. And now, since the horizontal is the opposite of 30 degrees, then we will go sine 30 is equal to whatever is the horizontal over 20. So from here, the horizontal will be 20 times sine 30. So as a vector will be positive 10. And the other one will be cosine. If one is sine, then the other one is cosine over 20. From here, the vertical component will be 20 times cosine 30. So then we can find that 20 times cosine 30 is positive because it's going north, 17.32 newtons. Do you have questions? So let's find the horizontal component and the vertical component of this vector here is between south and east. Starting from east, going 22 degrees. We have a vector that looks like this. The magnitude of it is 17 newtons, and this is vector F7. Now create the right angle triangle that includes the given angle. Whatever is on the horizontal will be the horizontal component. So F7 horizontal, and whatever is on the vertical will be the vertical component. F7 vertical. Now, again, the same logic. If we are finding the vertical component, then we will use sine. So sine 22 is equal to F7 vertical over 17. From here, F7 vertical as a vector will be 17 times sine 22, and it is going down, so will be negative 6.37 newtons. And when we are finding the horizontal, since it is the adjacent, then we will use cosine 22 f7 horizontal over 17. So from here, f7 horizontal will be positive because it is going in the east direction, and the magnitude of it will be 15.76 newtons. Let's move to the next example. So we have 33.0 Newton vector at 15 degrees south of west. So it's between south and west. And it is starting from west, has an angle of 15 degrees. And the magnitude of it is 33 Newton, and this is vector F8. Let's create the right angle triangle that includes the given angle. Whatever is on the horizontal is the horizontal component. And whatever is on the vertical is the vertical component. So now the vertical component, since it is the adjacent, will be found using sine. So sine 15 is equal to the vertical component over 33. From here, the vertical component will be, since it is going down, is negative 33 times sine 15, and this will be 8.54 newtons. And the horizontal component, since it is the adjacent, we will use cosine. And this will be F8 horizontal over 33. So from here, F8 horizontal, since it is going west, is a negative, and will be 33 times cosine 15, and will be 31.88 newtons. Questions, concerns? So find the horizontal and vertical component of vector F9 that is 15 newtons northwest. So this is that specific case when there is no angle given. So it is between north and west. And what do we have here in terms of the vector? Since the angle is not given, we have that vector right in the middle. So this is vector F9 and has a magnitude of 15. Right in the middle of the quadrant means 45 degrees. Both of them are 45 degrees. This is 45 and this is 45 as well. Which one are you picking doesn't really matter on this case when the angle is the same, because whatever angle you pick, it's fine. So draw the right angle triangle that includes the given angle. If you want to go with a vertical, you are great, you can do that. And then whatever is on the horizontal is the horizontal component. So this will be F9 horizontal. And whatever is on the vertical will be the vertical component. And the magnitude of both of them, vertical. The magnitude of both of them will be the same. So when we are finding sine 45 or cosine 45, they have the same value. And if you have done math, then you should know this. So this is why the magnitude of the two of them will be the same. And when we are finding the one, it doesn't really matter which one. Let's say that we are finding the vertical component over 15. Then the magnitude of the vertical component will be 15 times cosine 45, or sine 45 is the same as 10.61 newtons. Since it is going in the north axis is positive, so as a vector, this is what we will have. And this is the vertical component, and the horizontal component will be with the same value, 10.61, but since it is going in the west direction, will be negative 10.61 newtons. Because what we are dealing here is an isosceles triangle. This is, I think, how is it called? Now, the other example here is when we have a due north. So we have a vector, as we said, it goes like this, F10, and the magnitude of this vector is 25. So that means that the length of the line segment that represent this vector is 25. So the horizontal component of this vector will be equals to 0. There is no way that we can create a right angle triangle here. The horizontal component is equal to 0, while the vertical component of this vector is the magnitude of it in the positive direction, positive 25 newtons. Or when we have the case when, like in the example 11, where the vector is going west. So we have a vector that goes like this. This is vector 11, or F11, as 25 newtons due west. So now the horizontal component of this vector will be negative because it is going west, and with the same magnitude of 25 newtons, while the vertical component will be equal to 0. There is no mark that this vector is leaving in the vertical axis. Another one is when we have vector 12, or example 12, F12. So it is this vector here, vector 12, F12, with a magnitude of 25 newtons going south. So the horizontal component of this vector will be equals to 0, while the vertical component will be equals to negative because it is going south, 25, which is the magnitude of this vector. And the last one, I think, is due east. So you have a vector that is due east, F13, 25 newtons. So the horizontal component of this vector will be positive 25 because it is going in the east direction, and the magnitude, or what is leaving, the mark that is leaving in the east, is the same as the magnitude of it. And 13 vertical will be equal to 0. Okay, so this concludes the lesson for today. In your notebook, you have to find the horizontal and vertical component, and this will be the practice for you for those vectors that you have here. Okay.